Trigonometry Part 2. Alright, we are rolling in to the second part of trig. You already learned the ratios, the formulas, so now we're going to see what are we going to do with this stuff. So we're going to start with the steps. So in trigonometry, once you learn the ratios, what you can do is you can use them to find missing sides or angles. So that's the point of this lesson right here, is we're going to figure out how can we use the ratios to find the different missing sides or angles of right triangles. So first thing we're going to do is we're going to write down steps. There's just 3 steps, and no matter what, whether you're trying to find the sides or the angles, you're going to use the same steps. It's kind of a backwards order from what we've been used to, except for the first step. So the first step, and we did this in the last video as well, and when we've been practicing, is that we want to circle the angle of reference. So remember, the angle of reference is what are we trying to find, or what is the trig ratio referring to, because the trig ratio is always referring to an angle. So circle the angle of reference, or what point of view are you looking from. Okay, step 2. Once you circle that, then you're going to determine, just like you did before, how are the 2 sides related to that angle. So determine how the 2 sides relate to that angle. And remember, when we do that, we're looking for opposite, hypotenuse, or adjacent. So those are the 3 things that you could possibly have when you're labeling the sides. So far nothing is new. Here's the tricky part, is that you don't know, because I haven't told you yet, are we using sine, cosine, or tangent. In the last examples, the part 1, I always told you, find the cosine of x, find the sine of x, find the tangent of x. I'm not going to tell you that. That's what you have to determine. So this step 3 is where you look at the 2 sides that you have and you determine the trig function that you're going to use. So the trig function is going to change with every problem. You're only going to use one, but it's going to change, and you'll determine it based on the 2 sides that you have. So just a refresher, remember that you have the sine is equal to opposite over hypotenuse, the cosine is equal to adjacent over hypotenuse, and the tangent is equal to opposite over adjacent. So just to have that down and ready to go, and we're going to do 4 examples that show you how do I determine what trig function that I actually use. So let's go to the next slide. There are 2 things that we're going to look at. How do I find a missing angle, and how do I find a missing side? So I'm going to do the missing angles first. And what you want to do is go along with the steps with me, and we'll hopefully figure out what we have to do. So the first step, if you look at your steps, is to circle the angle of reference. So the angle of reference is our x degrees. This is what we are trying to find. So this is my point of reference when I figure out how is 12 and 15 related to x. So I'm going to start with 15, because hopefully we know that 15 is your hypotenuse. So I'm going to label that with an H. Then I have the 12. The 12 would be opposite of x, because remember this would be adjacent, the one that's right next to it. So the 12 is opposite. So I have 12 and 15, which are opposite and hypotenuse. So look at your formulas. Which one of the trig functions uses opposite and hypotenuse? The sine does. So we are going to use that the sine of x is equal to opposite over hypotenuse. So this is the formula that we're going to use to solve. And all you're going to do is plug in the information. So remember, the sine of x is representative of a degree. We don't know the degree, so we're going to keep that as x. Opposite side is 12, and the hypotenuse is 15. So recall from the last class we did, I showed you how to put this in your calculator. So we need to solve for x right now, and it has the sign with it. So in order to get rid of the sign, we have to take sine to the -1 degree. So we're going to do the sine of -1 and then is 12 over 15. So in your calculator you have to hit the second key and hit the sign button so the sign of -1 pops up, and then type in 12 divided by 15 and parentheses and hit enter. When you do that, you will end up getting 53.1. Now you can use different abbreviations. I'm not going to trip too much about how many parentheses that you use. If you want to be technical, you probably want to put 53.13. I always like 2 decimal places. So this is the degree right here of the missing angle. All right, let's try another one. Okay, let's look at this triangle. So this triangle, again, we're looking for the angle. We have a different point of reference, so we're looking right here at this x degree. So let's ask ourselves, how is 4 related to the x? Okay, well, this one over here is the hypotenuse. That's the longest one. So you either got the opposite or adjacent. This is going to be opposite, and the 10 is going to be your adjacent. So this one here is going to be adjacent. So which one of the functions use opposite and adjacent? The tangent. So we're going to use the tangent of x is equal to opposite over adjacent in order to solve this problem, because that's the information that they gave us. So again, we're going to leave the x alone because that's what we're trying to find, is the x degrees. The opposite side is 4 and the adjacent side is 10. So again, to solve for x here, I need to take the tangent of -1. I have to do the opposite of tangent in order to move the tangent over to the other side. So in your calculators again, you would hit the second key and the tangent button to pop up the tangent of -1, 4 divided by 10, and parentheses. When you hit equals, you will get roughly 21.8 degrees. So again, that is your missing degree in this triangle. Okay, now what happens if I have to find a missing side? This is a little bit different, but it's the same process. So you're going to follow the same steps. So start by circling the angle of reference. So we're not going to look at the 90 degrees. We never do. All the 90 degrees indicates to us that, hey, ding, 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 we can do trigonometry. We are looking at 55 degrees. That is the other angle they gave us. So how is 20 related to 55? 20 is your hypotenuse, and the x is going to be your adjacent side. So how are adjacent and hypotenuse related? What function is that? That's your cosine function. So the cosine of x is equal to adjacent over hypotenuse. So this is why you always want to have your formulas ready, or just remember SOHCAHTOA, and that will help you. So now this time we know the cosine of x degrees. We know that x is 55. So instead of leaving the x alone like we did the last time, we're going to plug in x as 55 degrees because x represents 55 degrees. Adjacent is x and the hypotenuse is 20. So now what we're going to do is we're actually going to, in your calculators, you're going to type in what is the cosine of 55. And you will get a very long decimal. And my rule is use 4 decimal places here. If you don't, your decimal or your answer is going to be really off, because the shorter the number of decimals you use, the more inaccurate it is. So always use 4. So when you type in the cosine of 55, you're going to end up with 0.5735, and it keeps going, but I'm going to stop there, equals x over 20. So now the easiest thing, I think, well, hopefully you're seeing to yourself that x over 20, in order to get x by itself now, I need to multiply by 20 on both sides. And that will cross that 20 out. So now all you have to do is do 20 times 0.5735, and you will get x equals 11.47. So this represents the missing side, or the adjacent side, right here. Alright, let's try one more, missing side. So again, same thing, let's circle our point of reference. Our point of reference is always the angle, which is 20 degrees. Next, step 2 is determine the two sides, how they relate to the 20 degrees. X is your hypotenuse, and the 10 is going to be the opposite side. Hopefully you thought of that before I wrote it down. So what function uses opposite and hypotenuse? Your sine. So the sine of x degrees equals opposite over hypotenuse. Again, we know the x degrees is 20, so we're going to plug that in as the sine of 20 degrees equals opposite of 10 over hypotenuse of x. So again, this time you can actually go into your calculator and type in what is the sine of 20. So when you do that, you will get the sine of 20 equals 0.3420 something something blah blah blah. Again, 4 decimals, perfect. Equals 10 over x. Now this time, it's not going to be as easy because in order to get rid of the fraction over here, we would have to multiply by x. And that isn't really going to help us out. So I think the easiest way to do this is let's turn this into a proportion. Any number in the world is always over 1. So we can take this decimal and put it over the number 1, and wham bam, you got yourself a proportion. And so you can just cross multiply like this. And so you'll get 0.3420x equals 10. And then divide by 0.3420 on both sides. And you will end up with x equaling 29.24. And there you go. Hopefully this will help you out a little bit when you are working with your trigonometry functions, and make sure that you're always having your fractions ready to go and you have your formulas next to you so you don't make a mistake and you always know which one to use.